Hi, welcome to EG BTech channel. Myself Ravi Kumar. Please subscribe our channel and share to your friends. In this video, I am discussing to solve a problem on balanced star connected load. That is, if the given load is in the form of star, then how to calculate the three-phase system parameters. That is, phase voltage, phase angle, phase current or line current, active power, reactive power or apparent power. Okay. For example, I am taking one problem, that is three equal impedances 8 plus J10 ohms are connected in star. Then that star load is connected to 440 volts 50 Hz three phase supply. Hence calculate the three phase parameters: phase voltage, phase angle, phase current, line current, active power and reactive power. Okay, first of all, in the given system, you must draw the three phase circuit based on the given values. In this problem, the given system is star connected system. That's why the load is in the form of star. Okay, this is the example for balanced system. That's why all impedances are equal. Then we consider the three phase is R, Y, B. That is R, Y, B. Then the given three phase supply is, the voltage is 440 volts 50 hertz. This is the three phase supply also. Hence the given impedances are equal. That's why it is a balanced system. They draw the, what are the values given for impedance is 8 plus J10, 8 plus J10 and other impedance also 8 plus J10. Okay, that is all three impedances in star connection are equal. That's why it is a balanced star system. Okay, in balanced star system, how to calculate the three phase circuit parameters? First of all, you have to mention, write down what are the given values given in the problem. That is, by default, the voltage given, supply given in the system, in the problem is line voltage. That is, the line voltage given is 440 volts and given frequency value is 50 hertz. Suppose in the problem he is particularly mentioning the phase voltage 440 volts. Suppose then you have to consider VPH equal to 440. Without considering phase voltage, by default in the problem the given voltage is line voltage, that is VL equal to 440 volts. Remember this, the the point should be considered, the line voltage is very important in three phase problems. The voltage supply by default it is taken as line voltage, and also the given values are impedance values. That is, by default it is a phase impedance, that is the impedance should be connected between the phases. Then the given value is 8 plus J10 ohm. It is a rectangular form. Then you must consider the rectangular form change into the equivalent polar form. Okay, for 8 plus J10, the polar form is 12.81 at an angle 51.34 degrees. Okay, this is the impedance value, given impedance value in polar form. Okay, these are the given values. Then first consider, find out the values. What are the values we have find out? That is, first value is phase voltage. That is, it is denoted by V suffix PH, that is phase voltage. In star system, we know the relation between the line voltage as well as phase voltage. That means in star system, in star connection, that is VL line voltage equal to root 3 phase voltage. That is line voltage equal to root 3 into phase voltage. This is the relation between the line voltage as well as the phase voltage in case of star connection. But here we require the value of phase voltage only. Then what is the equation? VPH equal to VL by root 3. What is the value of VL given in the problem? That is 440 volts by root 3. Then you can simplify the equation. You will get here 254.03 volts. So this is the phase voltage for the given line voltage 440 volts. Then what about second bit here? In this problem, the value of second bit is, that is phase voltage. Remember, the phase voltage of the system you can find out from the impedance value in polar form. Already we can find out the impedance value in polar form, that is Z equal to 12.81 at an angle 51.34 degrees. The given 8 plus J10 impedance you must convert into the polar form. In the polar form, the phase angle phi, you can consider the angle of the impedance. So that is taken as the phase angle 51.34. Therefore, the phase angle of the system, that is considered phi. It is denoted by the symbol phi. Then phase angle of system is 51.34 degrees. Okay, na? Remember, you have to calculate the phase angle of the system is, you must find out the impedance value in polar form. In the polar form, what is the angle should be obtained? That angle is called the total phase angle of the system. Okay, that is second value. What about the third value here? You have to find out phase current. That is C bit. You have to find out what is the phase current in this star connection. We know in star system, what is the condition between, what is the equation, relation between line values and phase values of the currents? That is, in star system, line current equal to phase current. And also in this problem, the D bit also line current. That's why you have to calculate at a time both values, or after finding phase current, you can find out the line current. That's why in this problem, the phase current, which is denoted by the symbol is IPH. That is phase current IPH equal to, we know the formula, that is from Ohm's law, V equal to I into Z. From that, I equal to V by Z. It is a phase value. That's why you have taken the phase voltage and also automatically the given impedance are phase impedance. Then what is the value of phase current we are calculated in first bit A, that is 254.03. What is the ZPH value, that is 112.81 at an angle 51.34 degrees. That is only angle. Then you can divide by taking only magnitude values 254.03 by 12.81. Then you can make calculations. The current, the magnitude of current value is 19.83 amperes. Then the angle becomes, when the angle in the form of division, when it is going to numerator, the angle becomes minus. That's why the angle of the current value is minus 51.34 degrees. But the magnitude of current is 19.83 amperes. Therefore, phase current IPH equal to, the value is, magnitude is 19.83 amperes. Then what about D bit in the given problem? That is, you have to calculate what is the value of line current. We know the given problem is star connected system. Then in star, what is the relation between the line current as well as phase current? That means in star system, we know in star system the value of line current is equal to the value of phase current. That is, line current equal to the phase current. Therefore, what is line current? IL. That equal to, how to denote phase current? IPH. We know the value of phase current is 9.83 amperes. That is, the same value is line current. Therefore, IL equal to IPH equal to 19.83 amperes. So that is the D bit. Then what about next value? We have to calculate powers. That is active power as well as reactive power. That is, next bit is E bit. We have to calculate active power. We can denote the active power with the letter capital T. Okay, then in three-phase system, what is the formula for active power? We know active power P equal to root 3 VL IL cos phi, or in the form of phase values 3 VPH or IPH cos phi. Okay, in the star current system, the phase voltage equal to the, that is VL equal to root 3 VPH. From that, VPH equal to VL by root 3. Then root 3 time will cancel. Again root 3 VL, IPH equal to IL. Both are equal. That's why root 3 VL IL cos phi. But both formulas are same. One value is in the form of line values. Another formula is in the form of phase values. Then you can replace the values which are find out. That is root 3 into, we know the line voltage. The line voltage is given supply voltage. That is root 3 into 440 volts into IL value we can find out. That is 19.83 into cos phi. What is the phi value? That is the phase angle of the system. We have to calculate already the phase angle, that is what is the angle in the impedance value, that is the phase angle of system, that is 51.34, that is phi value. Hence cos phi nothing but cos of 51.34 degrees. Then you can multiply the values, are you will get 9.44 in the form of kilowatts. Therefore, for every value in the problems, you have to find out the what is the final value. Reactive power P equal to 9.44 kilowatts. Okay, this is the formula for the active power. Remember, the formula is root 3 VL into IL into cos phi in the form of line values, or in the form of phase values 3 into VPH into IPH into cos phi. So that is the formula for active power. Similarly, what is the final value you have to calculate is, that is reactive power. Which is denoted by capital Q. We know the same, the reactive power formula is root 3 VL IL sin phi. It is reactive, that's why we have sin phi. Or in the form of phase voltages 3 into VPH into IPH sin phi. Okay, that is one formula is in the form of line values, another formula is in the form of phase values. Hence, we can replace the values, that is root 3 into what is VL value 440 volts, and what is the IL value 19.83 amperes into sine, what is the phi value, that is 51.34 degrees, that is phase angle of the system. Then you have to make calculations. The value of reactive power is in the form of kilo, that is 11.81. What is the units for reactive power? kVAR, kilo volt ampere reactive. So this is the value of total reactive power of the star connected load. That is, therefore, reactive power Q equal to 11.81. The units of reactive power is VAR. The find out value is in the form of kilo, value should be obtained. That's why you have to write down, you have to mention the units of reactive power is kVAR, kilo volt ampere reactive. Then after finding active power and reactive power, in some problems also you have to find out what is the apparent power. Okay, in this problem there is no finding of apparent power, or suppose some problems asking you have to calculate what is the value of apparent power, that is S. It is denoted by letter S. Then the simple formula is root 3 into VL into IL. This is the formula for apparent power. Already we know the values of VL, that is 440, and we know the value of IL 19.83 in this problem. Then replace VL value as well as IL value. Then we have to find out the apparent power in the form of the units of apparent power. We know, that is, the value should be obtained in the form of kVA, that is kilo volt ampere. Okay, the units of active power is kilowatts. The units of reactive power is kVA or kilovolt ampere reactive, and the units of apparent power is kVA. Okay, na? By using these formulas, you have to find out the all three powers: active power, reactive power, as well as apparent power. These are the main calculations in the problem of the balanced star system. Okay, that is, you must draw the star system according to the given values. Okay, that is, all impedances are equal. In this problem, 8 plus j10, that is, the impedance values are equal, connected in the form of star. That's why you can draw balanced star system which is connected to three phase supply, that is 440 volts 50 hertz supply. Then the supply voltage by default, the given supply voltage is line voltage VL equal to 440. Other than in some problems he is particularly mentioning the phase voltage is. At that case, you have to find out, you have to write down the phase voltage is 440. Otherwise, by default, most probably in all problems, the supply voltage given is line voltage in case of star. Okay, that is 440 volts. Suppose it is delta, then in delta we know phase voltage equal to the line voltage. That is by default, the given voltage in case of delta system, VL equal to VPH equal to, for example, 440. That's why it is a line voltage as well as it is a phase voltage in case of delta system. But in this problem, the given system is line star connected. That's why by default the given voltage is the line voltage. Remember, by default, the given voltage in star system is line voltage. From that line voltage, you have to calculate what is the phase voltage. That is VL equal to root 3 into VPH. We know the formula VL equal to root 3 into VPH. From that, we have to find out phase voltage VL by root 3. And similarly, in the given Z problem, there is the impedance value. The rectangular form of the impedance value, you must convert into the polar form. In the polar form, what is the angle obtained in calculations? That angle is called the total phase angle of the system phi. Okay, that is the phase angle. After finding phase angle, then you have to find out the phase current. We know in star connected, phase angle equal to the phase current. Phase current equal to the line current. IL equal to IPH. Then we know Ohm's law. That is in form of impedance. What is the Ohm's law? V equal to I into Z. That is in star connected system. In star connected system, what is the phase voltage here? VR is the phase voltage, or what is the line voltage? VRB between the phases. Okay. Here in star, the voltage between RY, that means the voltage between RY, that is VRY. Similarly, the voltage between YB, VYB. Okay, this is the R here, not. It is okay, this is the Y phase between V R Y. Similarly, this is B and this is R. What is the line voltage here? V B R. And between Y and B, that is V Y B. Okay, here all values are equal. Why? Because in star system, that is, it is balanced. Balanced means total impedance value is equal in each phase. Similarly, current also equal. Then similarly, voltage is also equal. That's why you can find out one voltage only, then all three voltages are equal. Because, but in three phase, what is different here? All three phase currents or all three phase voltages are displaced by 120 degrees each other. For example, what is the phase voltage here? The phase voltage is the value of phase voltage nothing but 254 volts. We find out in this problem. That means by default, initially VRY equal to, or suppose line voltage also, that is 440 volts, for example. This is at an angle 0. Similarly, what is VYB voltage? That is same voltage, 4 volt, 440 volts, but what is the phase angle? 120 degrees. Similarly, VBR, we know what is the voltage here, same voltage, but displaced by angle is minus 240 volts here. So that means all magnitude values are equal, but difference is all voltages or all three phase currents also displaced by 120 degrees each other, but the magnitude of voltages as well as the magnitude of currents all are equal in case of balanced system. That's why we have to calculate the value only one at a time. There is no need to find out all three values in balanced system. Okay. Okay, this is the, in this way you have to make calculations, find out all values according to the given balanced star system. Remember, in star system, in the problems by default the given three phase supply is the line voltage, that is VL. From that you have to find out the phase voltage. Okay. Please subscribe our channel and share to your friends.